Hello everyone, welcome to Coders Camp, and today we are going to cover another binary tree problem, that is binary trees with factors. So we are given an integer array and we have to return the number of binary trees we can make from the given values. And the constraints given here is each non-leaf node's value should be equal to the product of its children. So now let's understand this problem with an example. So here is our given example, and we are going to form binary tree with factors using this value. So here every value given is an individual binary tree. So 2, 4, 5 and 10 individually forms each binary tree. So now if you see 4 as the root node, you can form a binary tree with 2 as its left and right children, because it is given we can use this value any number of times. So this is one binary tree, and moving on to 5, 5 doesn't have any divisibles here. Moving on to 10, if you see 10 as the root node and the values are 5 and 2. Or otherwise 10 as the root node, its left child is 2 and the right child is 5. Both are agreed to be the binary tree with factors. So if you see the left and right children's product is going to be the root node's value. So in total we can form 7 binary trees from the given value. So how are we going to approach this problem? So we are going to get the help of dynamic programming to determine how many trees can be formed using the given values. So we are going to have two pointers I and j to scan the array, and for every I we are going to check whether this number has the capacity of being the root element of the binary tree. That is, for example, if we take 2, with 2 you can form one binary tree, but there are no lesser elements than 2, so you cannot have its children. So moving on to our next element 4, 4 can be the root element because it has its factors 2 and 2 as its children. So for every element we are going to check whether that element can be a root node. By using that, we are going to fill its corresponding DP array, that is how many binary trees can be formed by keeping that element as the root node. After filling all the cells in the given array, that is for every element how many trees can be formed, we are going to send the sum of this array as a result, that is the total number of trees can be formed. Before understanding the pattern of how we are going to fill our DP array, I want us to understand why and how we are going to fill those values. So here the pattern we're going to use is, if we can form a tree with root node R, then the number of trees that can be formed is equal to dp of its left children into dp of its right child. Consider we are having a node 40 and its children are 4 and 10. So further, these 4 is having children 2 and 2, and 10's children is 5 and 2. So if you consider 4 alone, using 4 as a root node, you can form 2 trees. That is 4 as the individual tree and 4 comma 2 comma 2 as one more tree. So you can form 2 trees. The same way, if you consider 10 alone, you can form 3 trees. That is 10 as a single tree and 10, 5, 2 as one tree and 10, 2, 5 as another tree. So you can form 3 trees. So by having 40 as your root node, you can form 2 into 3, 6 trees. How? So you can have 40 alone as a single tree, or this is tree 1, and 40 with only children 4 and 10 as another tree. This is tree 2, and here what we have showed is tree 3, and we can swap 5 and 2 to make it tree 4, and we can swap 4 and 10 to make tree 5, and further after swapping 4 and 10 you can again swap 2 and 5 to make tree 6. So you can form the product of how many trees formed by its left child into the product of how many trees formed by its right child. So by using this technique, we are going to fill in our DP array and arrive at our solution. So let's start our problem by having two pointers j and I. We are going to check for every I whether it can be a root element, and j is going to scan the array from j to I. So now our DP array is filled with ones already because every value is an individual binary tree. So already we can form one binary tree with the given values. Now starting from our second element 4, why second element? Because first element we have already filled 1 here in our first box, and we cannot have further children for the number 2 because it is the least or smallest element in the given array. So starting from our second element, we are going to check whether the previous elements in the array, that is the values before 4, are dividing the 4. Why dividing the 4? Because we are going to construct a binary tree with factors. If we can multiply and bring a value, then we also can divide that value by the factors. So now I'm going to check 4 by 2 gives the remainder 0. Yes, it gives the remainder 0. So 2 is a factor of 4. In this case, we can form a tree with root node 4 and its left child as 2. So now we are going to search our right child. So how do we search our right child? If these two number gives the product of the root element, then dividing the root element by one value gives the other. That is, if x into y gives us the root value, then y is equal to r by x. By using the same thing, we are going to find our right element. So now 4 by 2 is going to be 2 again. We are going to check whether our array is having the value 2. Yes, array is having the value 2. As we can use the values any number of times by the problem statement, we can have 2 as the right children. So now we have constructed a tree by having 4 as our root value. So it's time to fill our DP array at position 1 because this is the position of 4 here in the given array. So already it is having value 1. We are going to add another tree that we have formed to that position. So as I said, it should be the product of how many trees we can form from its children. So here the both left and right child is 2. So by 2 we can form only one tree. So 1 into 1 is going to give you one tree. So already one value is there. We are going to put plus 1. So updating the value of 4 as the root element, it can form two trees. Now that we have updated, the number of trees can be formed using value 4, moving our pointer I to 5. So 5 is a prime number. It should have 1 in the array, but array doesn't have 1, and also the numbers less than 5 given in the array are not factors of 5. So in this case, you can form only one binary tree by using 5. So still we are having the value 1 in the place of 5 and moving our pointer I to 10. So now checking whether the elements before 10 in the given array are factors of 10. So starting from 2, we are going to divide 10 by 2 and the remainder is 0. So now we clearly can say 2 is a factor of 10. So consider 10 as the root node and 2 as its left child. So now we are going to check its right child, that is 10 by 2 is going to be 5. We are going to check whether 5 is present in the given array. Yes, 5 is present in the given array, so 5 can be its right child and it can form a binary tree. So as I said, it is going to be the product of DP of its left and right child. So now the left child is 2, so the trees can be formed using 2 is 1. Also by 5 also 1, so 1 into 1 is going to be 1. So far we have one binary tree already present by using the value 10. So adding one more 1 to the position, updating, there can be two trees formed by using 10. So now we have checked with 2. Now it's time to check with 4. We are going to check 10 divided by 4 gives us 0. No, it is not equal to 0. 4 is not a factor of 10. So moving our pointer j to 5. So now checking 10 modulo 5 is equal to 0. Yes, it is equal to 0. So 5 is a factor of 10. So we can form a binary tree with root node 10 and 5 as its left child. Now time to find its right child. It's 10 by 2, 2. Whether 2 is present in the given array, yes, it is present in the given array, so it can form a tree. So now product of left and right child. So the product of left child is 1 and product of right child is also 1. So 1 into 1 is equal to 1. Already 2 is present in the cell. So we are going to add one more tree along with the 2. Now we completed iterating our array with last value and our DP array is updated. So now it's time to calculate the total number of trees that can be formed with the given values as sum of this DP array. So the sum is equal to 7. So overall 7 trees can be formed from the given array with factors. So this algorithm works in big O of n square as we have two pointers I and j to loop through the given array twice. So now let's get into the code. As every time we're going to compare the lesser elements alone, I'm going to sort my given array. So once that is sorted, I'm going to declare my DP where it is given the answers may be too large, so the answer modulo 10 power 9 plus 7. So as the values can be larger, I'm going to declare my DP array as long of length arrays length. So I'm going to fill my array with value 1. So once all that is done, I'm going to have a map which is going to help me to get the index of my left and right child easily, or search for whether my right child is present in the given array or not. To search it in constant time, I'm going to have a map and I'm going to save all the values with its corresponding indexes. So now our DP array is ready, our map is ready to search for the indexes. So now let's have two loops to have our pointers I and j. J is less than I because it will iterate till where our I pointer is. So I'm going to check every time. Our pointer I is going to be the root node and I'm going to check whether array of j is going to be the left child. So for that, if its modulo is equal to 0, then it is the factor of the root node. Then I'm going to calculate my right value. After calculating the right factor, I'm going to check if that is present in the given array or not. If that is present, then I'm going to get the index of that and calculate my DP array. That is my DP of left child into DP of right child. So once I have updated, I'm going to add the values in my DP array. And finally return the answer. So now they have said our answer should be in modulo. So we are going to declare one more variable, int mod. This is nothing but 10 power 7, 10 power 9 plus 7. So wherever we save the value, we are going to do a mod. So here we are updating our DP. So overall value percentage mod. Same way we have calculated our answer. So finally before returning, I'm going to do a mod. and our answer should be in int. We have declared our answer as long, so converting it into int before returning the value. So let's run. So yes, let's submit. Yes, the solution is accepted. And thanks for watching the video. If you like the video, hit like and subscribe. Thank you.